Yeah, just don't ride your bike through Louisiana. That's where I'm from, though, so I don't have a choice. Okay, so we're ready to get started, and we're right on time. Thank you guys for coming. We're going to follow on with the presentation we did yesterday with using fail to ban, scanning asterisk logs, and generating access lists in Cisco routers. So here's a test setup. Everything's local. I'm not going to make you guys try to boot up your own distributions and try to hack. We're not going to go there. I got everything contained here, so this should be pretty good. Anyway, we have, where's my laser pointer? Oh, not prepared. See, I'm goofing around, and I forgot my laser pointer. Ta-da! Okay, laser. Okay, this is our router. I have the units right here sitting up, so it's actually physically here in the room. We have, this is going to be on a virtual machine on my laptop. I'm going to be pretending to be a hacker to hack myself, 192.168.1 network. The router has just the two networks on the interfaces, LAN, WAN, and we're going to have a couple of PBXs sitting back here, just running Asterisk 1.6. running fail to ban, and of course the Asterisk server is going to recognize an attack and send the access list over to the Cisco router. So we're going to refer back to this from time to time. First thing we want to talk about, very important, almost a critical setting in SIP.conf is always auth reject. Can anybody tell me what that actually does? Yes. So if you have an attacker trying to enumerate your extensions and figure out what extensions you have on your PBX so they can target those extensions specifically, always auth reject will send back the same response to the attacker whether that extension is on the box or not. So we're going to demonstrate that, how that works. So bear with me while I get the proper demo set up here. So here's my attack vector, or my attacking unit, and it is going to attack. This is the Asterisk server. This is the actual, no, we're not going to use that one. This is the actual Asterisk server that is going to be attacked. SIP show peers. We have some peers down here. We have 101, 102, and we're going to attack extension 101. And we're going to show you SIP set debug on. And currently, we do not have that parameter set. So what we get in return is a very short message. The attack comes in to enumerate this extension, and what do we get? A reply going back to the attacker that says not 404 not found. Well, what we're going to do is change that parameter and see what the difference is. We're going to change this to yes. Restart asterisk module, reload module chan SIP, and we're going to attack it again, the same. And now you see we get an actual dialogue of the call. So basically what happens is finally it's an unauthorized. So an enumeration attack, depending on that setting, the attacker can distinguish whether you have actual extensions or your specific extensions on your PBX or not extensions on your PBX. Full SIP dialogue, so this is abbreviated. You get the registration attempt from the attacker. You get the trying back. You send the unauthorized back. The attacker sends an actual username, password, and then you send them the trying, and then you say forbidden bad authorization. So that's one setting that is really critical, and that's how that works. Any questions on always auth reject? It's very important to have that enabled in your system.
It looks like it's automatically set to yes and PBX 2.1.
In free PBX 2.11, it's automatically set to yes. Yeah, so bringing this to your attention because a lot of the old systems did not have this automatically set to yes. So there was a lot of question about why was it just not automatically default to yes in the source. But I think they've corrected that in the later branches. In the back? Any issues as far as? No, none that that I'm aware of. All the way down to 1.2. So it's been in the code for a long time. But like I said, it wasn't always turned on automatically. So enable ACL permit denies. So this is where we're going to start looking at very specific messaging from Asterisk and what it's actually doing. And we're going to go back. Now, currently, fail to ban is not running on this test system, so this is just a wide open system. So we're going to check on extension 101 and see what's there. Now we get we get a message that the device does not match the ACL. So in extension 101, I don't have anything set. We do have a permit deny in the basic options, which gets populated down to all the extensions when you use the basic options there in parentheses after the peer, SIP peer. So we're going to go ahead and turn on and say this hacker or this network is authorized to contact this extension. Reload chan SIP. We're going to hit it again. And now we have our typical unauthorized message. So we'll turn SIP debugging off. SIP set debug off. We'll hit that a couple of times there, and you see the registration. You just see a typical registration with the wrong password now in the general message. So this is what actually gets populated to the log file. All right. Any questions on ACLs? How to apply them, how to use them? Pretty simple. Everybody uses ACLs in here? Of course. All right. Fantastic. You guys. All right. Moving right along. All right. Permit denies. We're going to look at a denial of service attack. We've disabled fail to ban. And here we go. This is our SIP vicious. We're going to, I want to do a DDoS attack or DOS attack against a different one here, just to show you. So this is, we're going to try to hack extension 102 and the range of, this is the actual password setting. So we're going to do a range of passwords, 1200 to 1600. And real quick, that's so, how many passwords is that? That's a lot, huh? So you see this guy is still going. I mean, that's how quick. So we just, that's how quick it takes to attack a box. And that's basically, if you don't have anything in place to stop that attack, it's basically doing a denial of service on your box. So while this thing is running, while somebody's sitting there attacking. And that's a very small range of passwords. So somebody could hit you with 10,000 passwords on one extension, and the user on extension 102, their phone's trying to register, it's getting blocked, they're trying to make a call or set up a call, and nothing's happening because they're basically stopped all your services for that extension. A lot. If you'd like me to quantify, a whole bunch, tremendous amount. So what we're going to do is we're going to switch to the actual system that's running fail to ban. So here's the fail to ban log file that the Perl script that actually, when it runs fail to ban, or when fail to ban runs the ACL block script, it gives you the information here. So this is an active file. We've just tailed it, and we're just going to watch it and see the messages come across. This is the actual log file for Asterisk. So we'll see the log file entries in Asterisk go in here, and then there's going to be a slight time delay between when fail to ban is running, scans the log, and then actually puts the access list up. So we're going to get a good, and this is the actual fail to ban. This is the PC or the PBX that we're going to attack. It's a different IP address. And here's the Cisco router that we have the access list, SIP firewall, that we're going to put the access list in. So here we go. It's going to be 10. We're going to attack it. The same one, the same extension, and the same range of addresses. Okay, so we got stoppage there, and we see the logs, the Asterisk logs, and then we see the actual ACL script running because it put something in the changes, and now, okay, so now we have access list 523 just got applied, and it blocked that network, okay, and we still have 15 matches, 24 matches, so you can see from when it actually blocked the attempts, the SIP vicious was still trying to access the PC, but the gateway stopped it via the access list. So you have these counters. So when it first stopped, well, when we first ran this, it was 15 matches, and then a couple seconds later it was 24 matches. So you know the access list is actually working, it's stopping. Now it's 54 matches, right? Okay. So let's see. 69 matches. So actually SIP vicious is still running, trying to attack, but the access list is stopping it. Now let's see what happened actually. Now this is kind of weird, right? So we got a registration failed, and then all of a sudden we've got a host unreachable. So what actually happened there? Why did we get a host unreachable? Look at that. Right. So cookie for somebody who can answer this. I just attacked it. I stopped the attack, but yeah, you get a cookie. All right. Nice. Okay, so what actually happened here? So what is my password? Ta-da. Okay, so I set that range specifically for a reason, to demonstrate that even though fail to ban is running and it's going to block your attack pretty quick, what just happened here is SIP vicious was able to launch an attack to a specific extension on your system and was able to guess the password for that extension prior to getting blocked. So this is a very precarious situation because he's blocked. He can no longer attack from this IP address or this network, but like most hackers, like most good hackers do, is they take this information and they ship it off to somebody else on the internet, give that authentication information, say, hey, extension 102's at this IP address is password is 1234. So we'll just verify that real quick. And the password set up in the basic. And look at that, secret 1234. So this is an example of why it's really imperative. Your best defense against hackers is a great password that's not going to be cracked by a bunch of brute force password attacks. Because even if they're DOSing you, even if they're denying you service, the worst thing you can do is allow simple passwords that are easy to crack. Because what happens is you'll stop that attack right then, but then they may hold on to that password for days, weeks, months, and then come and attack you again when your defenses are back down, when you're not looking for an attack. So it's critical to have good passwords. APG, what is that? Advanced Password Generator. Nice. Sweet, 20 character passwords, that's awesome. Okay, so. All right, so now we're going to talk about remote PBX logging. So let's go ahead and clear the access list out of the router. I'm going to do that with that ACL delete script. I'm going to call that from and what number was it? 523. So we just called that script. It just gave us the prompt, go back to the router, and we see that 523 is no longer in there. So this is just an example of how you can control access list in the Cisco router without actually logging into the router, adding it manually or deleting it. It's all done through the Perl scripts that are running adjacent to fail to ban. All right, so we're going to turn the log back on for fail to ban. We're going to clear some of the log messages out here for the PBX. And we're going to turn this guy on. So actually, we're not going to use this guy. So this PBX1, this asterisk fail to ban PBX would be like the central logging server. So right now, we've just demonstrated that fail to ban is running on the PBX host itself. Now we're going to go ahead and set up remote logging from one of the other PBXs, let's say from this PBX, and demonstrate how the log files are going to go from this PBX to the other one, and fail to ban is going to run. So let's see. We have to turn on logging in Asterisk and logger.conf down at the bottom. Oh, it's already enabled here. So this mechanism is going to ship Asterisk logs to the actual syslog daemon on this PBX. And then on this etcr syslog.conf at the bottom, we're going to take that local 0, all the logs from local 0, which Asterisk is set for local 0, and we're going to ship them to 10.1.1.1. And of course, those configurations are already there, so we don't need to reload the daemon there. All right. So here is fail to ban running on the 10.1.1.1. This is 10.1.1.11. We're going to generate some traffic here, and it's going to send the logs over to this guy, and fail to ban is going to run. And notice we do not have any access list blocking, so we are free to hack. No, fail to ban is only on one server. Well, our syslog is on every device, right? Every PBX has syslog. I'm sending it to the server that has the fail to ban running. So fail to ban is reading the logs.
How does fail to ban know that traffic is going to one
Well, you set that up in the configs, so you know. Okay, so it didn't work. So I hacked this box, and let's see, I know he sent the log files over, but what actually happened? Did we set this guy up to receive the logs? Let's see. Our syslog.conf. So here are the commands. So the other PBX that was getting attacked was sending log files to this particular server, but guess what? He wasn't listening for those log files, so he never wrote the logs properly. So failed to ban never got any log messages, and so we have to tell it to, hey, listen for log file messages. And the local 0 log files, we're going to send those to var log asterisk messages. Okay? So we set those two command parameters on the receiving syslog server. And you have to restart our syslog process to reload the configuration. Okay. So now we're in this PBX that should be receiving the log files, and we're looking at var log asterisk messages, and this is the fail to ban log that you'll see it generate the ACL, and this is the PBX that's going to be attacked, and we'll go ahead and just change. Let's see. I want to do 100 to 1,000. So we'll get a bigger sample here. Okay, so it's being attacked, it's being attacked, it's being attacked, it's shipping log files. Is it working? Nope, still not working. Why is it not working? Any guesses? What'd I miss? Uh-oh. It did work. There was a delay. Yes. Very astute observation. There was a delay. Now, anybody want to guess why there was a delay? Shipping log files between servers? So this server that was being attacked is shipping log files. So you have, syslog has a buffer. So there's a delay from the time that syslog on this server buffers the logs and ships them over to the receiving log file, and then there's a buffer on that guy as well. So syslog has to take those messages in and scan the local 0 log message and put it to the right file. So there is a delay there, but failed to ban as soon as it got the log files in there. It still worked, and we take a look at the router, and the access list is in there. Okay, so now we can know we can't hack him. Yeah, she can tune. Yeah, she can do some tuning on it. See? So we got 3 matches. So that's a great example of how one system interacts to the other one. There's still a delay. Now, as an administrator, I would much rather see a slightly extended hacking delay of, 20 seconds or something like that than 5 hours worth of hacking. I got to get out of bed at night when I get a call from a customer that says, I can't make a phone call and figure out that he's being DOSed. So I think it's an acceptable delay. It's not very much. No, all of my stuff is local on net to me within my VoIP infrastructure. So it's basically on the same LAN infrastructure. PBXs, send the log files. If you have, I don't know that there'd be much delay on a WAN connection either, because the log files are really small. I mean, they're very small kilobyte files. That was a great question. We had that question yesterday as well. We're actually going to. I didn't build that to test. I was going to put this in. So the way Cisco IOS works differently between switches and routers. In routers, in an actual gateway router, you may see a performance hit with extremely large ACLs. I'm not talking a couple of hundred entries. I'm talking a few thousand entries. A couple of hundred entries, you're not going to run into any problems. On Cisco switches, on the higher end switches, they actually offload ACL functions to ASICs, so there's no load actually. So you could have an access list with 10 entries in it, or you could have an access list with 10,000 entries. There's not going to be any performance difference on those because of the way they handle it on the ASICs and the iOS. There are differences there. So you may get into some trouble on a router. But my particular scripts rotate through a range of 500 to 700. So at any given time, I'm only injecting ACLs between the number range 500 to 700. So, and yeah, when it gets to 700, it just puts the count back to 500 and deletes 500 and does another entry on 500. So as a service provider, the biggest thing, besides doing passwords, blacklist everybody, whitelist only the users that you want access to your systems. That cuts down the majority of attacks. But every now and again, say you have a remote home office user that is on a cable modem DSL, well, I tend to whitelist that whole network for that customer because at any given time their cable modem may reboot, their IP address is going to change, might be in the same the class C, or it might be in the same second octet, or it might be a whole different range. Might go from a 71 dot address to a 73 dot address. We see that all the time, but we still so we'll whitelist like the whole class A or something like that, just to make sure that if we don't get calls every time the cable modem reboots. Yeah, I used to work for Cox actually. Yep. Yeah, it brings back a lot of memories. Now, I'm in a unique situation where the majority, I'm facilities based, so the majority, 90% of my customers are on net to me. Actually, a lot more than that. So I'm only dealing with off-net users. I'm only dealing with onesie, twosies, little small offices or home office. So I might have only, I don't know, just a couple of hundred end devices that are on the open internet. So it's easier it's very easy, convenient for me to whitelist and go that approach. So this works great for me. So that's. Do we have any other questions about how the access list works, how the Perl scripts work, sending emails, putting? Sure, we can take a look at that. So on the PBX, the actual message that comes in, device does not match ACL. We're going to take a look at, what was it? Filter, asterisk. So here's the filters that Asterisk is running on. And there's it matching right there. I actually have these commented out. But it's catching on, I should not have that. Yeah, it's all in the white paper. When you go to the website to download the presentation, I've also have a Word document that has everything you can cut and paste out of it. Now, there is, just notice that from 1.4, 1.6, the way the log files are written, there are some differences, very slight modifications, very slight differences in the, I think a colon set or something like that, and there's an extra message before it gets to the wrong password. And what is it? So we currently blocked 266 already. That's awesome. So we know failed to ban's running, working fine. You can reload the configuration. When you do that, it clears everything out. Oh, what do we do? We didn't remove the... Got some more hits on it. Still working. 524. We'll go ahead and pull that out. Hits the router. No longer in there. Flood and attack. One guy ships the log file. Gets back in there. Get the wrong passwords. And it's back in there. So it happens pretty quick. One attempt. So here's the actual settings. This is the log path that we're looking at. This is the action we're going to call the ACL script in actions.d directory. Max tries, one attempt, ban time 10 seconds. The reason I have a low ban time is if for some reason it doesn't pick up on the first hit, which I've never had happen, but this guy's still running. You want that ban to be applied, and you don't want that IP address hanging out in fail to ban for a week or something like that, because somebody might come behind you and delete that access list, and if it's still a hacker, it'll get reapplied within 10 seconds. So that's pretty much it. I mean, the presentation has some good information. If you didn't see it yesterday, you can download it. And basically, this was a demonstration of what we presented. It shows you that it's working, works fine, lasts a long time. It's all automated. You don't have to get calls in the middle of the night. This stuff just works. You get emails when it applies. You got your changes log. You can go back and look at things that happened a year previous and figure out, do analytics on it. Any other questions about fail to ban and Cisco access lists? Yeah, so I got a phone that's in sync with my Exchange server. So what? You can pound on this one. 10.1.1.10. No, I would have to whitelist you to give you an opportunity to hack my network. All right. Yeah, I get plenty of emails. Now, literally, I mean, we don't get a lot of emails. It's like from my access list, 300 or 500 to 700, I get, it might take me a year and a half to go through to actually put, you know, when it starts. Yeah, before I recycle. I don't get many hits at all.
I'm not sure if that's what your first example was, but you could just run, even if you have multiple access servers, you could just run the fail to ban on each one, right?
Well, you could, but yeah, you could do that, but then you have to manage and maintain fail to ban as an extra service on every PBX. So say you wanted to add an ignore IP range, say you have a new IP range that you added to your network that you wanted to ignore in case you're getting banned, right? Then you would have to go touch all your PBXs that were getting phones from that. So it's a better situation in a carrier type environment to have one management event to manage one fail to ban service. Yes. That's a good point. So this is the script that actually logs into the Cisco router. And where's it at? And here it is, plain text. So that's why your fail to ban service, your RSys log, your central repository, the machine that's actually doing the work, it can't have access to the internet. It can't have access a very secure network. So that's why you don't want this thing sitting on all your PBXs, because if one of your PBXs gets cracked, they can get in here and now they have access to your router and open up all their friends to all the PBXs, and it's not good. It's not good. So that was a great point. Any other questions? Yeah, so in the email address, when it comes, when an access list gets applied, and I get the email to me, and it has a URL to execute that CGI script to automatically delete the access list if it was applied in error. Like if, because what could happen? Give me an example of why an access list could get applied in error. Yeah, you fat finger the password on a telephone, ship the phone out to somebody's house, they plug it in, and it starts hitting the network or starts hitting the PBX, and you get the wrong password log message. Fail to ban sees that as an attack and shuts that IP off. So that gives me a good, once I verify things are good, instead of having to log into the router, I just get the email, redo the IP address, have the customer reboot the phone, and I can click that link, take that access list out without having to log into the router. Yep. How we doing on time? We're good? Who's keeping time? Who's the timekeeper? Is there a timekeeper? Are you awake? Hello. All right, I think we're wrap it up. So y'all have any other questions, just let me know. We're 5 over?